Up to now, we've dealt with exponents that are positive whole numbers. What happens when that exponent is 0? Some of you know the answer to this. For example, what is 3 to the 0 equal to? Well, people who don't know the answer to this usually say it's 0, because they're used to things, anything kind of multiplication having to do with 0 would be 0. It turns out it's actually 1. But let me show you why this is. I think it's important for you to see this, because again, it's part of that, these are not rules we make up. These are theorems that we derive. Actually, this equal to 1 is a rule, but I'll explain that a little bit later, why that's true. Anyway, let's look at a pattern here. 3 to the 4th power is a product of 3 fours, and that would be 81. 3 to the 3rd power is 3 times 3 times 3, which is 27. You might see where I'm going with this. 3 to the 2nd is 3 times 3, which is 9, and 3 to the 1st is 3, which is, of course, 3. Now we get down to 3 to the 0 power. And here's where I think it's interesting, because there's nothing here. Does nothing mean 0? Okay, well, that's where you gotta be careful, because nothing in mathematics doesn't always mean 0. There's a difference between 0 and nothing. Oftentimes there is. So don't assume that because there's nothing here, because I'm multiplying no 3's together, right? If I'm multiplying 0 3's together, there's nothing to multiply. Well, let's look at the right side here and see if we can figure out why this is going to be 1. Because look what happens. Every time I lower an exponent, look what happens on the right. Do you see the pattern? We divide by 3. Divide 81 by 3, you get 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And guess what? 3 divided by 3 is 1. There you go. So, as a pattern, if we want this pattern to be consistent, then when we get to 3 to the 0, we're going to have to call it 1. So that's one reason why we define a number raised to 0 power equal to 1. And now, let's look at this. Here's another compelling reason, I think. If we looked at 3 squared divided by 3 squared. Okay. Well, what should that be? That's equal to 1, isn't it? Because I've got 9 divided by 9, or number divided by self is 1. Now, if we want the quotient rule to work, it'll have to be 3 to the 2 minus 2. Because the same base, we subtract exponents. So if we want the quotient rule to be consistent, I've got to be able to get 3 to the 0 here. And so now we have a string, logical string, which says that 1 equals to 3 to the 0. So there's another reason why we should call that 0. Like I said, this is actually by definition. It's not possible in mathematics to prove that a number raised to the 0 power is equal to 1. And the reason is I think rather interesting, because the first way exponents are defined, the first way we define exponents is with positive counting numbers. And so when you get away from the positive counting numbers, we have to expand our definition of exponents. And so we can't logically prove that x is 0 equals to 1, but we want it to be that way because it makes all the patterns fit nicely. So really this is by definition, and the symbol for by definition in math is a 3-lined equal sign, a triple equal sign. So by definition, x is 0 is equal to 1. That means any number raised to 0 is equal to 1. With one exception. This is provided that x is not equal to 0. So here's something you don't really have to worry about now. You'll worry about it in Calculus 3 if you go that far in math. how do you deal with 0 to the 0? Well, that's a mess, because we just said every number raised to the 0 is equal to 1, but yet 0 raised to any power is also always equal to 0. So what in the world is that equal to? Well, this summer in my calculus class, I gave a proof that 0 to 0 is equal to 17. So it was kind of strange. But don't go around saying that that I said 0 to 0 is equal to 17. It's actually, you can find a way to justify this equal to anything you want to. All right, so just a little tidbit trivia. Don't worry about this situation. It's called an indeterminate form, and we're not going to deal with it in this course. So anyway, there's the rule. Now let's apply it a few times. What is minus 2 to 0? It's not 1, because, as in the last video, the exponent only applies to the base. It doesn't apply to the negative sign unless the negative sign is included, is grouped together with the base. So this would be negative of 1. So 2 to the 0 is 1, but the negative sign makes it negative 1. Here's one. How about 13 times 17x to the 7th y to the 4th z cubed raised to 0 power. All right, well that's a long mess there. But x of 0 is equal to 1, which means really all this quantity, this whole quantity, as long as it does not equal to 1, doesn't equal to 0, as long as x, y, or z don't equal to 0, this whole mess is going to equal to 1. And 13 is multiplying it, so it's really 13 times 1 is 13. So there you go. That's an important step to getting to negative exponents, is to first look at the 0 exponent. And I want you to see that it's more than just a, well, it is a rule. It's by definition, but I want you to see the reasons behind it. I think when you see these reasons, these things tend to stick in your mind better. So, and if I take the trouble to go through all this with you, then I think it's important. If I think it's important, then who knows? It may show up on a test if you have me for a class. So, anyway, let's move on to negative exponents now.